Hello friends, my name is Sarang. So today we'll learn about the object-oriented programming in Golang. So let's get started. So I have this topics which you need to know when you're going to start object-oriented programming in Golang. That is struct, interface, encapsulation, polymorphism, composition, and comparable. Make sure that you understand each and every concept, and then you'll be able to do the object-oriented programming in Golang. Okay, so let's get started. So now what I'm going to do is the first thing is I'm going to create go.mod file. To create that, we're going to run go mod init, and we have to give the name of the module, which is example.com slash dev problem slash go oops. Okay, so this will create the go.mod file, which will create the name of the module that we have just given, and also the version of Go that I'm running, okay, in the machine. So now what I'm gonna do is I'm gonna create a main file. Okay, I'm gonna change the package to main because I want to make this main function as the entry point of the program. So the package and the function name should be same, main. Okay, so the first thing I'm gonna do is I'm gonna create a person struct. Okay, so the struct is nothing but a user defined type which contain the collection of fields and methods. Okay, so you can relate the struct to the classes concept that we have it in another programming language like Java and Python. Okay, so I'm gonna create a field called first name and then last name and then age. Okay, so using this struct, I'm gonna create a person object. Okay, I'm gonna give the first name as Sarang and the last name as Mar and the age as, let's say, 23. So right now I'm gonna just print out the content of this object P, which holds data like first name, last name, and the age. Okay, now I'm gonna run the program, so you can see that it has printed out the content. So what I'm gonna do is I'm gonna also create a another object, person object, with the P name P1, sorry. Okay, so I'll just change the first name. Okay, dev problems, and yeah, it will give the content of both the objects. Okay, so hope you understood like how to create struct, the syntax, and how we can add the fields inside it. We can add any types of field inside of a string, integer, boolean, anything. Okay, we can also write like a function inside this, let's say, which will return string. Okay, any type is possible inside the struct fields. Okay, so now what I'm going to do is the struct would also have the method specific to struct. So these are called receiver functions. So I'm going to create a function called walk. Okay, so I'm going to return one string saying that p dot name plus sorry, it's a first name, first name plus p dot last name likes walking. Okay, so I'm gonna add this, and here I'm gonna write the return type as string. Okay, so here I'm gonna call it using this object called p, and here I'm gonna write p dot walk, so it will give me the result as okay, so here it will also have, I have to get the string. Okay, so I'm gonna print out the result here. So it's like Sarang Kumar likes walking. Okay, so this is a receiver function which can only be invoked by the person object. So P is one of the person objects, and it's gonna be invoked by this object only. Even it can be invoked using any person object. Okay, but you cannot simply invoke it like this. Okay, you need to create the object and then use a dot operator to invoke the function, which is specific to the person struct only. Okay, so hope you understood that how we can create struct inside, how we can create the fields, and how to create the receiver functions. These are called receiver functions. Okay, so now what I'm gonna do is, hang on for a second. Okay, so now let's understand about the encapsulation here. So basically here in the Golang, the encapsulation is done in a very different way. So here the encapsulation is done using package oriented method. Okay, so right now what I've done is I have created a field, and these are all public fields. Okay, these are all public fields. That means it can be accessed anywhere in the package. Okay, so if I make it to the private field, like making the first letter as a small case, okay, so it will become the private fields. Okay, so let me change these things. Okay, I'm gonna remove all these things. Okay, so I've changed that to a private field, but then too I'm able to give the values to the fields, and even I can access it using access it here. Okay, so if I change the first name, it will give me the updated first name, which is not a good practice, because here the user is getting freedom to access this first name, because here in the main function and the person struct are in the same package. Even though the fields are private, the main function can access the private fields. Okay, so this is not encapsulation. Encapsulation says that if a struct fields are private, then it cannot be accessed directly like this. Okay, it can be accessed using a getter function that we'll understand now. Okay, so let's create another package, and I'm gonna give the name of the another package as something like structs, and inside that I'm gonna create a person file. Okay, so I'm gonna transfer this person struct here. Okay, now they are private fields. Okay, so here I'm again gonna create an object. P is structs.person. Okay, now if I'm trying to initialize the first name, it will give me an error saying that, let me hover over the first name. It is saying that unexported field first name usage. Okay, so this field right now is a private field. Okay, it cannot be used in any other package. Okay, it is private to this particular package only, which is struct. Okay, within the struct package you can access the private field. For an example, here you are able to access the private field, but in the another package, here you cannot able to access, because this is how the encapsulation is achieved in Golang. If you want to encapsulate some data, you have to move it from to the another package, and if you're trying to access it in another package, then you won't be able to access it, because uh, it says that it is unexported. If I just make it to a capital F, capital L, capital A, okay, change it here, making as a public field. So now it will allow me to assign values to the fields. So right now I can assign value without any errors. Okay, so this is how the encapsulation is achieved in the Golang. But a better way to assign value, okay, so if I change it to a private field again. Okay, so since it is a private field right now, so I cannot assign it directly, or I cannot even access the first name right now, because it is private. Okay, so how I can assign values to the first name, last name, and age? We can assign it using a setter function. Okay, so I'm gonna create one setter function. I'm gonna write set first name. Okay, I'm gonna write p dot first name equal to, I'll pass the first name here. Okay, and using this setter function, now I can able to assign the value to the first name. Okay, so I'm write structs dot person. I'm gonna create the empty struct because I cannot assign any values to the struct right now because they all the fields are private. So I'm gonna use the set first name. I'm gonna write as the first name as Sarang. Okay, now I'm gonna print out the content of the object P. Okay, so I will just try to run it. Okay, it has not given me the first name Sarang because here I have used a receiver function which is not a pointer based. Okay, so make sure you use the pointer based receiver function if you want to update the state of the object. So right now I'm updating the state of the object as a first name to the string that I'm providing here. Okay, so use the pointer based receiver function. Okay, so this is called pointer based receiver function. Okay, so here I'm gonna run the program and now it will give me the first name as Sarang. Okay, so here in the setter function you can also write a validation if the length of let's say f is lesser than 3, then we would like to raise a panic saying that just a second, invalid first name. Okay, so if you want to demo it, so if I just pass it a single string, so now it will give me an error in the console saying that invalid first name. Okay, you can also return the error if you don't want to panic. So if it's like this, then you can write return errors dot new, and here you can say invalid first name, and at the end also you will return the nil. Okay, so here you can just get the error. Okay, and just write if error is not equal to nil, then you just have to print the content of that error saying that error dot error. Okay, now it will give me it will not panic, it will just print out the error message. Okay, so you can do both the ways. Here I have added the validation. So this is encapsulation. So using the setter function we are able to set the values of the fields that is present in the struct. Okay, and we will not able to access it directly, all the fields. Like if I do p dot, I'm not getting an option to access the fields directly. I can only set it using the setter function. Okay, so what if I want to get the value of the first name? Okay, so you can create a getter function, again p person. Okay, first name, so you have to return a string, just return p dot first name. Okay, make sure it's a pointer base to avoid memory unnecessary copying in the memory. Okay, so this is a getter function. Okay, getter function, and the best practice is to write the field name and the name of the function as the same. So here is a first name, here is also first name, so that in the Go, if any other programmer checking this method, he can understand it's a getter function. And if you want to write a setter function, just write set before the field name. Okay, so here what I'm gonna do is I'm gonna get the first name and I'm just gonna print out the first name. I'm gonna remove this. Okay, I'm able to access the first name. Okay, so that is, I have not set the, okay, since there is error, so it was not able to set the first name. I will just write the right string, and here it has given me first name as Sarang. So this is how you can access the private field, and this is how you can set the private field. Okay, set the value of private field. Okay, so we have achieved the encapsulation. So let's check it again. So if you want a struct, okay, and all its data to be encapsulated or private, okay, then you have to move it to another package, okay, and set those field values using a setter function, and get the values of those fields using a getter function. Okay, and in another package you have where you are creating the person struct, you have to invoke the setter function to set the private field values and get the private field value using getter functions. Okay, and make sure to add this round brackets after the func keyword to tell Go that this is a method first name specific to the person struct only. Okay, hope you understood about the struct here. So right now let's understand about we have covered encapsulation here, so let me cover it, write it here. So now we will cover interface, and using interface let's see how we can achieve the polymorphism in Golang. Okay, so before moving to the polymorphism, so I just missed one part, that you can also create a person object in different way. So here I'm gonna write a function new person. Okay, I'm gonna return the person object here. Okay, so how I'm gonna return is I'm gonna write the return keyword and create the person object, and now I want to initialize all the fields. So I will accept the parameters as first name, last name, and age. Okay, these both are string and this is integer. So here what I'm gonna do is I'm gonna write first name fn, last name and sorry, and here I'm gonna write a. Okay, and I have written the person object. So this is how you can also create the person object. So previously we were creating like this. So the another way to create is create a function, okay, accept all the parameters which will help to initialize the private fields, and then create the object directly here and return it, so that the user will get that object directly. Okay, so this is called constructor. Okay, if you're coming from another language, you might be know what is constructor, but here in Golang there is no concept of constructor. You just have to create a normal function, and using that function just return the struct that you want to return. Okay, and here you can access the struct directly. So struct dot, you can write new person. Okay, so I'll write something like Sarang, and again age 23. Here I will directly get the person object here. I don't want to set any values. I'll directly get the first name using a getter function. Okay, here if I change it to, let's say, dev problems, so now it will give me the dev problems. Okay, so right now what we have understood is there is a constructor that you can create and treat one simple function as a constructor. There is no rule for constructor in Golang. There is no constructor in Golang. Okay, so create a normal function, return the struct, create the function, create the object inside that function, and return that struct itself. Okay, so since here in the setter function we can also set the values, in the constructor also we can set the values for that particular struct. Okay, if you want, if you're missing the validation here, just write the validation logic here, okay, before setting the value, and if it fails, then panic, then panic. Okay, so this is how you can create objects also in Golang. Okay, so hope you understood about the constructor. Now let's go to the interface and polymorphism concept. Okay, now let's understand about the polymorphism. So for that, first let me create one directory with the name poly morphism. Okay, so here I'm gonna create a file with the name shape. Okay, so here first I'm gonna create a interface with the name shape. Okay, so this is how you create an interface in Golang. Okay, so if you're creating a struct, just write struct keyword here. If you're creating an interface, write the interface keyword over here. Okay, so the interface is same as the other programming language, where you just write the method signature, or you just declare the method, and all the other classes or struct can implement those interfaces. Okay, for an example, you can declare one function like render inside the interface, and the implementation will be done of this method will be done using a struct. So for an example, I'm going to create a struct circle. Okay, and I'm going to create a struct uh, square. Okay, now this to struct can implement this render function which is present in the shape interface. Okay, so now how we can implement we can make the struct circle to implement the method render. So what you need to do is we have to just create a function, and this function should be specific to the circle, as you know, receiver function, and you just have to write the function of the interface that you want to implement. Okay, so it is so easy that in the other programming languages we just have to something, write keyword like implements shape, something like this. But in the Golang we don't have to write any keyword to implement the functions of interfaces. You just have to create a receiver function specific to that struct, and write the name of that function the same as the interface function. Okay, so here I'm just gonna print out, as this function render function is having a contract or having a signature saying that it will not return anything, so we'll not return anything. So we'll just print out the something in console that circle is getting rendered. Okay, now if the square struct want to implement the render function, so what we need to do is we just have to change that receiver function to square, and that's it. Now the square struct is implementing the render function which is present in the interface name shape. Okay, so I will just change it to square here. Okay, so now so this is about the interfaces and how the struct can implement the interfaces. Okay, so now let's understand about the polymorphism. So let me go to the main file, and here I'm gonna declare a variable, let's say C, and the type of the variable C would be like so let me write polymorphism shape. Okay, so now I'm gonna create a object of circle. Okay, so it should be CLD. Okay, so see, as you can see on the left hand side, okay, I have the type as shape, and on the right hand side I have the type as circle. So circle is a struct and the shape is an interface. Okay, so I can also create the object of square here also. I'll just change it to S. Okay, so now see, on the left hand side the variables of type shape able to access or able to accept the struct circle and square. Why? Because this both struct is implementing the functions of interfaces. If for an example, if I just comment this out, okay, now it will give an error saying that cannot use circle because it's the type doesn't implement the polymorphism shape, as the methods are missing. Now what this means is, in the circle struct we are missing this interface method called render. That's why on the left hand side we have said that to the compiler, saying that they should be of type shape, but the circle is not of type shape because we have not implemented the function render. So if I uncomment this, now we have implemented the function render. Now it will compile it properly. Okay, so it is just CNS is just saying that these variables are not used, so I will just change it to here. I'll just write it in a fmt package. Okay, so you just understood about the polymorphism now. So this shape can have more than one forms. So the shape is having a form of circle, the shape can be a form of square. Okay, so this is how you can achieve polymorphism in the Golang. Okay, so I think so it's very easy. In the Golang they have not given any keyword where we have to explicitly say that we have to implement some interfaces. Here you just have to create a receiver function of a particular type and just write the method that you want to implement of that particular shape or the interface. Okay, so if I just run this, so let me call the render function dot render. Now okay, so it is giving me cannot use render as that. Okay, so these are type void, so since it's not gonna return anything, so I'll just change it like this, and it will just say circle is getting rendered and the square is getting rendered here in the console. So as you know now that the achieving polymorphism in Golang is very easy as different languages. Okay, on the left hand side you can have the same interface, but on the right hand side you can write any struct you want until unless that struct is implementing all the functions of the particular interface. Okay, so this is how you can achieve polymorphism in Golang. So after this we will understand about the composition and comparable. Okay, so now let's understand about the composition. Okay, so I'll create a directory composition, and here inside composition directory I'm going to create a Go file named car. Okay, so here I'm going to create three structs. One is engine and another one is wheel struct, and the last one is car struct. Okay, so inside this car struct I can embed the engine struct and also the wheel struct. Okay, so this is called composition. So having a struct inside another struct is called composition. That means you can also relate this to the real world example where the car has an engine and car also has the wheel. Okay, so in an object oriented way you can also think of and you can create struct in this way where you have separately created the struct and then you have added in the another struct which actually makes sense. Okay, so this is called a has a relationship. Okay, since car has engine and wheel, so this is called a has a relationship. In Golang there is no inheritance. Okay, there is no concept of inheritance in Golang. You cannot achieve inheritance in Go. So you can do something like composition here where you are embedding the struct inside another struct. Okay, so here I'm gonna write a few fields inside the engine struct called horsepower, and here I'm gonna write wheel dimensions of type int, and what I'm gonna do is here I'll give one car field name as car name. Okay, so now I'm gonna create the object of car where I will accept the let's say car name of type string and horsepower and wheel dimension of type int. I'll return the car object here. Now I'm gonna create here the car object where the car name will be car name which I will receive in the parameters, and engine is gonna be, so I have to create a struct here because it's embedded inside the car. So horsepower will be here HP, and wheel is gonna be like this where the wheel dimension is gonna be WD. Okay, let's go to the main file and create one of the object of car. Okay, see composition new car where the car name I will just give A, and horsepower I'll just give 600, and wheel dimension I'll just give 1 2 3. Here I'll just use the fmt package println function to print out the content of the car object. So here you can see that there is a outer curly braces. Inside the outer curly braces there are two inner curly braces, which says that this car struct has two embedded struct. One is of type engine, another one type of wheel. So okay, so this is how you can embed the struct inside another structs. Okay, so now let's do further more things. Let's create a getter function to get the horsepower. Okay, so there is a good way, there is another way to achieve composition, and that is also easier than this. Okay, it's just a syntax wise it is easy, concept is same. Okay, so I'll just write here engine. So I've just created a getter function uh, to get the horsepower, which is of type int. I'll just write e dot hp here. Okay, and I'll also write a getter function for wheel dimension. So I'll just write vw wheel, and here I will write wheel dimension, which will return int, and I'll just write w dot wheel dimension. Okay, so here I have written two getter functions. So if you want to get the wheel dimension here, okay, so since in the car you have embedded two struct. Okay, so now if you want to get the horsepower using the car object, okay, so how you can get here is, so here if you want to invoke the horsepower method, so you have to do something like c dot engine dot hp. Okay, and if you want to invoke the method of wheel dimension to get the wheel dimension of the particular car, so you just have to write this and you will get the horsepower and wheel dimension in the console. Okay, but here there are only two struct, engine and wheel. But if understand that if there are so many structs, then in order to call the method you have to keep on calling the struct, and the dot operator you have to keep on adding it, and you have to drill down to that struct in order to get to that function. Okay, so if you don't want the user to don't want to drill down to that struct in order to call that particular function, and if you don't want the user to know that there is an engine and the wheel struct inside a car, then what you can do is the simpler syntax would be just remove this variable engine and wheel field from the car, and just change this to small e and this to small w. Okay, so now the syntax would be more easier. You just have to remove the engine. It's gonna be c dot hp and c dot wheel dimension. So now the hp and the wheel dimension now are part of the car object itself. We don't have to write like this engine dot hp. So it seems like if we write like this, it seems like we are exposing that to the user that there is a struct inside the car engine, and the engine has a horsepower. So if you don't want to do this, just write this simpler syntax, and this will also give us the same result, 60123. Okay, so we have just made it very simple here. We just removed the variables, and now whatever the properties and the method the engine and the wheel has will be a part of car. Okay, so it's sort of like an inheritance, you can think of like that, but it's not a completely inheritance. Okay, so now what if both the function will have the same field name? For an example, let's say the engine would have a name. Okay, so I'll just write it small to make it private. So, and the wheel would also have the name. Okay, so now I'm gonna create a function quickly here saying I'll return the name, and this will return the name of the wheel. And here I'll also create a method for engine, which will return the name of the engine. Okay, so now here it should be a string, and also here it should be a string. Okay, so now if I just call from here, right, so here if I call the c dot name, So it is telling it is getting confused. It is telling ambiguous reference name because since the car and engine, the engine and wheel has the same method called name. Okay, the method of wheel is returning the wheel name, and the method of engine name is returning the engine name. Now the compiler is getting confused that which name it has to invoke actually. So in order to remove this confusion, what you can do rather is just create a function inside a car. Okay, and you can write something like engine name. Here just return string, and you can return it like c dot, you can write as engine name. Okay, so here, no, it's not engine name, so here it should remove the c dot and invoke the engine one. Okay, so here it's also getting the ambiguous error. So here how we can get the engine function. So engine dot name. So this is how you can return the particular name of the field. So here, since the wheel and engine had a same function name, so the compiler was getting confused. So in order to remove the confusion, you just create a function for a car which will return the engine name, and inside that it will drill down to that struct and return that particular name of the function, name of the name engine, while calling this getter function name. And similarly you can also create a wheel name. Okay, so here you just change it to wheel dot name. Now if you can go to this, here you can easily get the engine name and also the wheel name. Okay, so here again we have not exposed this struct. Okay, so I have to initialize the names here, so I just have to get en. So I'll just write en wn. Okay, so name would be engine name, and here it should be wheel name. Okay, so I have to pass the parameter here, engine name. Let's say I'll just write b, and here I'll just write c. Okay, so engine name, wheel name. Oh, okay, I just have to write comma. Now it will give me the name correctly, b and c. Okay, so this is how you can hide the what do you say, the struct inside the another struct that you have embedded. Okay, and if both the struct have the embedded structs have the same method, like in this example I have given the name. Okay, this is same function. So what you can do is rather create a new function, okay, in the outer struct, that is a car, and just return out just return the or invoke the function which will return the correct data for you. Okay, hope that you have understood about the composition. If you have any doubts, you can write in the comment section. And now let's go to the comparable section, and this is a very easy one, so let me quickly show you. So if you can recall that we have created a person struct here. Okay, so the comparable means that how you can compare two structs. So I'm gonna quickly create two person struct. So here for time being, okay, so this is struct dot person, and here I will use that new person method, which will take name as, let's say, Sarang, and I will write dev problems, age, let's say 12. Okay, I'll copy the same. I'll keep the content of both the objects same. P object has the same first name, last name as P1, the same age. So if we just compare this to struct, so using the equality operator, okay, so you can just print out here saying that uh, both both the structs are equal. So here the comparison of both the structs will be made based on their content. Now both the struct are of same type, person type, and both have the same content. The same field has the same names. So if we just execute this, it will just give the answer as both the structs are equal. Okay, and if I just change this value of the last name of p object, it will not give anything. Okay, you can also log this if you want. They are not equal. Not equal. Okay, so this is how you can compare two structs of the same type. Okay, so and now let's say if I go to the person, okay, and if I add one more let's say a field which is not a primitive, it's a slice. For example, I'll just write middle name. It is of type string, so it is of type string slice. Okay, now if I go to that okay, so I'll just have to add this mn, and this will be of type string slice, and middle name, just write mn. Okay, I'll go to the main file. Now I just have to pass, let's say, not like this, new string. I'll just write a. I'll copy this. I'll just write a. Now before adding the middle name of type string slice, we are able to compare both the slice. But now since we have added the slice of type string, the compiler says that invalid operation, because uh, the struct can only be compared if you have primitive types, and if you have the types which have a dynamic memory like slice, map, okay, point, all these things. If you have this dynamic memory data structure in your struct, then you cannot compare it, and it's not a comparable. Since this slice and maps are not comparable, so you cannot compare the structs. And as soon as I remove this middle name, so we have seen that if I remove the middle name from the person also, okay, now it will be able to compile and it will give me the result. So make sure, like, while doing this, if you're comparing, you should only have the primitive data types inside the struct. And let's say if you want to compare using you have to compare the struct, but you should also have the dynamic memory data structures like slice. So what you can rather do is, you can I'll just write again middle name of types, this one. I'll just write mn string, and here also I'll write middle name mn. Okay, so rather what you can do is just create one function of person, and this will check the equality. It will do the equality check, equals p1 person, and I'll just write this will return boolean saying that whether these two structs are equal or not. Okay, so if you have primitive data types, you can directly do using the equality operator. And if you don't have a primitive data structure, or if you have something, a slice inside the struct, and you want to compare, then create a new function called equals, and then you can compare your give out the comparison result over here. So I will just write length of, let's say, p dot middle name is equal to p1 dot middle name length. Okay, if both are equal, then just return true. Okay, else return false, or you can just directly return it here. Okay, so this is how you can create a new function where you are comparing both the struct of same type and why you want to create, because inside this struct there are a few data structure which is not comparable. You cannot compare the string slice because it has a dynamic memory layout, so that's the reason. Now what you can do here is you just remove this and just write string slice here, just write middle name a and copy it here. Now if I call p dot equals, sorry, p dot equals p1, okay, I'll get the result back whether they are equal or not. So I'll just write if r, I'll write mm, both the structs are equal. Okay, so this is using equals function. So hope you understand about the comparable. Okay, so I have covered all the concept, and let me know if you have any doubts in the comment section. And yeah, it's for a new programmer, it will be little difficult to understand all these things, but if you know about the object oriented programming already, and if you're coming from background like Java, Python, then you would be very easy to understand the Golang object oriented programming. Okay, so let me know in the comments, and please subscribe to the channel so that I can keep posting such videos, and